Welcome dear students, welcome back to physics class. I hope you are all safe in this lockdown period. Okay, so in last two classes we have discussed the book back exercise and I sent the PDF also. So in the some question I ask you to do homework, so it may be 3 to 4 questions, so try to do the homework for those questions. Now so we are going to discuss some more numericals from the second chapter. Okay, so now some important conversions. So how to convert one kind of unit into another kind of unit. Okay, so about each unit conversions we are going to see. In the first one is 1 kilometer per hour, that is equal to how many meter per second. 1 kilometer per hour is equal to how many meter per second. We know kilometer means it is nothing but 1000 meter. And 1 per means divided by per hour. 1 hour how many minutes? 60 minutes, and 1 minute is equal to 60 seconds. So 60 into 60, that becomes 3600. 3600. So the 20 cancel. Then using 2 tables, 5 2s are 10, then 18 2s are 36. Therefore 1 kilometer per hour is equal to 5 by 18 meter per second. Okay, this is the first conversion. So we'll rub it. So 1 kilometer per hour is equal to 5 by 18 meter per second. Similarly, if you want to convert the meter per second into kilometer per hour, you need to do inverse, that is 18 by 5 hours. Okay, moving to the second conversion. The SI system of force, the SI unit of force is Newton, but in CBSE system the unit of force is dyne. So 1 Newton is equal to how many dyne? 1 Newton force is equal to how many dyne? It is nothing but 10 to the power 5 dyne. Okay, so in a SI system the Newton is the unit, whereas in CBSE system the force is denoted by the unit of dyne. Okay, so 1 Newton of force which is equal to 10 to the power 5 dyne. Okay. So how this value comes, that you will be learning in laws of motion lesson. Second unit is over. Moving to third conversion, Joule. Because SI unit of energy is Joule, no? So 1 Joule is equal to SI system of energy is Joule. 1 Joule is equal to how many H? H is the unit to represent the CBSE system of energy, which is equal to 10 to the power 7. So in previous case force we have seen SI unit of force is Newton. So 1 Newton is equal to 10 to the power 5 dyne. Similarly 1 SI unit of energy, that is 1 Joule, is equal to how many CBSE unit? That is 10 to the power 7 H. Okay. Then calorie. Calorie also we know 1 calorie is equal to how many joules? 1 calorie is equal to 4.18 joule. This here also we converted, because calorie is another one unit, but SI unit is only the joule for energy. But 1 calorie is equal to how many joule? 4.18 joule. So 4.8 joule is equal to 4.8 into 10 to the power 7 F. So 4.18 into 10 to the power 7 F, which is equal to 4.18 joule. Okay, so this also over. Then next one is electron volt. Electron volt. 1 electron volt is equal to how much? Actually, where we use the electron volt means in your 12th standard dual nature lesson. Okay, lesson number 11 we'll use this unit, 1 electron volt, which is nothing but the metal have a free electrons. Mostly the metal have a free electrons. So normally we need to remove an electron, free electron, from the metal surface. For that, some minimum amount of energy is given to the metal surface, in which the electrons are induced to escape out from the metal surface. Such electrons are called photoelectrons. So in the photoelectrons, how much energy is given to remove the free electron from the metal surface is called work function. So in a work function case, we'll use this electron volt. So 1 electron volt is nothing but, what is the charge of electron? The charge of single electron is 1.6 into 10 to the power minus 19. Okay, coulomb. This is the charge of, what is it? A charge of a single electron. We know potential difference is equal to work done by charge. Some work done is required to move the 1 coulomb of charge, which means to move the 1 coulomb of charge, 1 joule work is done, then it is equal to 1 volt. Therefore, 1 joule is equal to 1 coulomb into 1 volt. Okay, therefore 1 electron volt is equal to 1 electron ki evlo voltage kuduthirkom, which is nothing but what is the charge of an electron? It is nothing but 1.6 into 10 to the power minus 19, and coulomb into volt is equal to joule. Okay, so this is the another one conversion. 1 electron volt is equal to how much? Joule. Then next conversion is 1 gram per centimeter cube. 1 gram per centimeter cube, or we may use 1 gram centimeter power minus 3, which is equal to how much? Which is equal to gram centimeter cube. This is the unit, CBSE unit, but we need to convert it into SI system. So multiply 1000 and divide by 1000, the value won't change. So 1000 kilogram per meter cube. So 1000, here also 1000, 1000 into 1000, it is vanishes, no, yes. So you will get the gram. So 1000 kilogram per meter cube, 1000 kilogram per meter cube. Because meter we are converted into centimeter, so meter we are converted into centimeter, so 10 power 2 centimeter, 1 meter is equal to 100 centimeter, no, yes, the whole cube. What you will get? 10 power 6 meter cube. In the 10 power 6 denominator இருக்கிறது மேல போச்சுனா என்ன ஆகும்? 10 power 3 to 10 power 3 ன்னு மாத்துவோமா? You know how they converted the unit? 1 gram per centimeter cube, no? Yes. In 1 gram, 1 gram is equal to how many kilogram? 1 by 1000 kilogram. Okay. So centimeter we are converted into meter. So this is how. So the denominator value become numerator. The sign changes, and after cancel, which is equal to the 10 to the power 6 எப்படி split பண்ணலாம்னா 10 to the power 3 into 10 to the power 3 meter power minus 3. But 10 to the power 3 is nothing but 1000, and another one 10 to the power 3 is kilo, then gram meter power minus 3 it comes. So 1 gram per centimeter cube is equal to 1000 kilogram per meter cube. Next unit, 1 liter. In 1 liter is equal to 1000 milliliter, no. So instead of specifying the milliliter, we may also use centimeter cube. Milliliter we can use a centimeter cube. So 10 to the power 3 is nothing, 1000 is nothing but 10 to the power 3 centimeter cube. So 1 liter is equal to 1000 centimeter cube, or 10 to the power 3 centimeter cube. Okay. The next one is electrical energy unit. What is the unit of electrical energy? The unit of electrical energy is next 1 kilowatt hour. Actually 1 kilowatt hour is a unit to measure electrical energy. Watt is the unit of power, and kilowatt is the unit of electrical power. Kilowatt hour is the unit of electrical energy. So in 1 kilowatt, so we can split and write it as 1 kilowatt hour into 1 kilowatt into 1 hour. So 1 kilowatt is equal to 1000 watt. 1 hour is equal to 3600 seconds. So watt second is equal to joule. The unit of the combination of watt and second becomes joule. So 36 after 10 to the power 5 joule, or we may also write it as 110 power you give here. So already 10 power 5 is there, now 110 is here. So 10 to the power 5 into 10 to the power 1 becomes 10 to the power 6 joule. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule, or 36 into 10 to the power 5 joule. The next, horsepower. In Medberg hemisphere experiment, 1 horsepower is equal to 746 watts. In 1 horsepower is equal to 746 watts. You know, motor, electrical motor, the motor which we use in the mixer grinder, wet grinder, washing machines, and irrigation motor. Okay, all the motors they used to specify the unit is horsepower. It is 1 HP or 2 HP, 3 HP like. In mixer grinder we'll use 1 horsepower, that is equal to 746 watts. Okay, then 1 degree. There is 1 degree also we had discussed. So 1 degree is equal to, what is 1 degree? 2 pi by 360 radian. After the simplification, the answer is 1.7 into 10 power minus 2 radian. So this also we can write it as 0.017 radian. Okay, so 1 degree, this is the value of 1 degree. And then 1 calorie per gram. Or gram, in 1 gram, 1 calorie per gram. 1 calorie per gram is equal to, it is 4.18, no? So 4180 joule per kilogram. Joule per kilogram. Okay, 1 calorie is equal to 4.18 joule. So 1 calorie per gram, which is equal to 4180 joule per kilogram. And next one, 1 kilogram weight. 1 kilogram weight. Kilogram is a unit of mass, and weight is a unit of what? Yes, it is mass into gravity, no? So 9.8 Newton. 1 kilogram weight is equal to 9.8 Newton. Kilogram is a unit of mass. So 1 kilogram mass irukku or object weight edhukku equal ah irukumna 9.8 Newton. Suppose if the object mass is 60 kilogram, then its weight is equal to 60 into 9.8 Newton. Okay, in the weighing machine what we are measuring, it is not our actual mass, it is weight, because it works under the principle of spring balance. Next conversion of unit is Tesla in a magnetic field. So magnetic field is Tesla is a unit to represent magnetic field. So 1 Tesla is equal to 10 to the power 4 Gauss. This is SI system of unit. This is CBSE system of unit. So 1 Tesla is equal to 10 to the power 4 Gauss. Next one, 1 ampere per meter. 1 ampere per meter or 1 ampere meter inverse is equal to 4 pi into 10 to the power minus 3 orsted. Okay, அதாவது ஒரு மீட்டருக்கு 1 ampere current flow ஆச்சுன்னா அது எவ்வளவு orsted equal. We know that current carrying conductor produce magnetic field around it. So the conductor having a length which is equal to 1 meter, the conductor having the length 1 meter and 1 ampere current flow through it, then which is equal to 4 pi into 10 to the power minus 3 orsted. Okay. Then last one, Weber. Weber also another one unit to represent the magnetic field. So 1 Weber is equal to 10 to the power 8 Maxwell. 1 Weber is equal to 10 to the power 8 Maxwell. Okay. So these are the various conversion of unit which we are going to use in solving some numericals. Now we will solve some numericals. The questions related to errors and the combination of errors. Moving to the exercise. Look at the question. Now we are going to solve some questions which is related to combination of errors. Look at the question. The repetition in measurements of certain quantity in an experiment gave the following values. So the first measurement is 1.29, second measurement is 1.33, third measurement is 1.34, fourth one is 1.35, fifth is 1.32, sixth is 1.36, seventh is 1.30, eighth measurement is 1.33. For greater accuracy, they have a 8 set of measurements. Okay, we need to find the mean value, then mean absolute error, relative error, and percentage error. So using this 8 measurements, these are the errors we need to calculate it. Okay, so how to do this? Listen, first we need to find mean value. So the mean value as follows. Sum of data by number of data, no? So add all the data. 1.29 plus 1.33 plus 1.34 plus 1.35 plus 1.32 plus 1.36 plus 1.30 and 1.33. So sum of data divided by number of data. 1, 2, 3, 4, 5, 6, 7, 8. So divided by 8. So what is the value you get? You will get the following value. The value is finally 1.3275. The mean value is 1.3275. By rounding the digits, the mean values become finally, it is, see, this is 5. So the next number is greater than 5, so it becomes 8 and this vanished and 7 become 8. Now compare the 7 and 2. The 7 is more than 5. So this number vanishes and 2 become 3. Therefore 1.33. We got the mean value. It is 1.33. Next one is mean absolute error. Before finding the mean absolute error, now first we should find the absolute error. So the absolute error is, it is nothing but it is the difference of this mean value with the individual value. This first one, delta A1. Delta A1, which is the difference of 1.33 minus first value. What is the first value? 1.29. Similarly, second value 1.33 minus 1.33. Third value is 1.33 minus 1.34. And the fourth value is 1.33 minus 1.35. Then fifth value is 1.33 minus 1.32. Then seventh value is 1, 2, 3, 4, 5, sixth value 1.33 minus 1.36. Then 1.33 minus 1.30. Then eighth value is 1.33 minus 1.33. So what is the value you will get? Only the magnitude, no. So the magnitude means the difference may comes in the plus or minus, but we will consider only the plus. So this is delta A. So the difference is 0.04. Then here the difference is 0. So 0.00. This is delta A2. Similarly, delta A3 is, what is the delta A3? It is 0.01 because minus only it comes, but minus and plus we consider only the plus. Then delta A4, what is the value? The difference is 0.02. Then these are all absolute error. I am finding only the absolute error. So each one is absolute error. 5. What is the value? It is 0.01. Then delta A6 is 0.03. Delta A7 is, it is 0.03. Then delta A8, the eighth measurement, it is 0.00. So these are the values 0.04 to 0.00. So each values are the absolute error, but we need to calculate the mean absolute error. So how can you get the mean absolute error? The mean absolute error is, so delta A mean, it is given by sum of data by number of data. We need to add all this value and divide it by 8. Then finally we get the error. Okay. So the error would be 0.0175. 0.0175. As usual, you need to round up to the second decimal. So after round up this is 5, this is more than 5. So this number vanishes and 7 become 8. Then the mean absolute error is 0.018. This plus or minus. So we calculated the mean absolute error. Next, we are moving to the relative error. Okay. In some cases, again in a second decimal we need to convert. No. So to convert in a second decimal, see, the 5 vanishes, 7 become 8. This is more than 5. To the second decimal we need to round up the digits. So finally it becomes 0.02. This is the mean absolute error. Okay. Next we are going to calculate the relative error and percentage error. Next we need to calculate the relative error and the percentage error. To calculate the relative error, it is the ratio between mean absolute error and mean value. The relative error, it is the ratio between mean absolute error, that is delta A mean, to arithmetic mean. What is arithmetic mean? This mean value is also called arithmetic mean. This mean value is also called arithmetic mean. So by taking the ratios, so plus or minus 0.02 divided by 1.33. Yes. So this is a ratio we'll have, and this value is plus or minus 0.1503. By taking the ratio, this is the answer you will get. Okay. Then as usual, we need to round off to the second decimal. By round off to the second decimal, this is less than 5 vanished, this is 0, and this is 5, and this one is an odd number, so this become double. So plus or minus 0.02. So this is the relative error. The relative error you need to represent in percentage. Okay. So percentage error is, in the answer percentage that is the percentage error. Okay. So what is the percentage error? Percentage error is nothing but the relative error or answer. This is the relative error. So plus or minus, the relative error is plus or minus 0.01503 into 100. In the percentage error, this is percentage error. So by saying this in percentage, we'll have multiply pannunga. So plus or minus 1.503, or which is equal to, as usual, round off to the second decimal. Namak enna varum? Plus or minus, idu vandu less than 5, so vanishes. This cannot change, less than 5, 0. So 1.5%. So we have calculated the percentage error also. I repeat once again. We have 8 measurements in an experiment. We need to calculate the 3 errors. What are the 3 errors? The first error is arithmetic mean or mean value. So sum of data by number of data. After getting this answer, we need to round off to second decimal. This is the mean value or arithmetic mean. If in the arithmetic mean, individual measurement oda compare panna porom. Arithmetic mean individual measurement oda compare panni kedacha value da நமக்கு என்னது absolute error. அந்த absolute error வந்து நம்ம magnitude மட்டும் தான் எடுத்துறோம். இந்த absolute error ஓட sum or mean, the mean value of the individual absolute error is called absolute mean absolute error or absolute mean. So idhile as usual, round off to the second decimal, we got the error, mean absolute error. Next we are moving to relative error and percentage error. In relative error, it is the ratio between absolute mean to arithmetic mean. What is absolute mean? Absolute mean is 0.02. It is plus or minus. But maximum possible value நம்ம என்னதான் எடுத்துப்போம்னு சொல்லிருக்கேன். For maximum possible value, we consider only the plus, not minus. Okay. So plus or minus the mean absolute error to arithmetic mean. Okay. By taking the ratio, we'll have 0.01503. But in round off digit to the second decimal, less than 5 it vanishes. It become 1. So 0 it become vanishes, and this 5. This is even an odd number. So 5 are greater than 5. Then the odd number become added 1. So 1 plus 1 become 2. So this is the relative error. And the relative error percentage la solradhu, it's a percentage error. Okay. In a percentage error 1.5 or accurate solna 1.5, approximate solna it is 2%. 1.5 around of 2 கிடைக்கும். So எப்பவுமே relative error percentage la சொல்றதா whatever percentage error. Okay. Moving to next question. Okay, now the second question. The length and breadth of the rectangle, it is given. Look at that. That is the rectangle. In this rectangle, the length and breadth are given. The length is 5.7 centimeter plus or minus 0.1 centimeter. Similarly, the breadth of the rectangle is given. The breadth of the rectangle also is 3.4 centimeter plus or minus 0.2 centimeter. Find the area of the rectangle with the errors limit. They are asking you to find the area of the rectangle with the errors limit. So first we will find the area. So area of the rectangle. What is the area of the rectangle? The area of the rectangle A is, it is equal to length into breadth of, it is equal to length into breadth. So we need to calculate the area of the rectangle. So first we will find, this is the measurement. These two are, this is the breadth measurement, this is the breadth error. This is the length measurement, this is the length error. So length into breadth. The length is 5.7, the breadth is 3.4 centimeter. Therefore, 5.7 into 3.4, we need to multiply and we will get the value 19.38. After the multiplication, it is 19.38 centimeter square. By round off to the second decimal, the maximum value, already we know, this is greater than 5, so this vanishes and 3 become 4, but the 4 is less than 5, that vanishes. Finally, it is 19 centimeter square. Therefore, the area of the rectangle is 19 centimeter square, but we need to calculate with the error limit. To calculate the error limit, we know the formula. What is the error limit formula? It is delta A by A, that is equal to plus or minus, it is ratio between delta S. What is the formula we will use? Length by breadth, no, S. Delta L by L, delta L, length into breadth, multiplication formula, yes. Length error by length measurement, breadth error by breadth measurement. Okay, so plus or minus, what is the length error? The length error is 0.1 by the length is 5.7 plus the breadth error is 0.2 divided by the breadth is 3.4. Okay, so this is the unit. Then using cross multiplications, finally we have plus or minus 0.1 into 3.4 plus 0.2 into 5.7 divided by 5.7 into 3.4. After the simplifications, the answer is, this is 0.34, that is 1.14. Yes, this value is 0.34, that value is 1.14 divided by 5.7 into 3.4. Then the final simplification is going to be calculated, listen, which is equal to plus or minus multiplication of these two terms, that become 1.48 divided by 19.38. Okay, so this is delta A by A. Okay, because we need error in limit only, no? So delta A by A, area we have calculated. The next step, see, in next step, delta A only we need to find. Therefore, delta A is equal to plus or minus 1.48 divided by 19.38 into area. What is the area of the rectangle? It is 19 centimeter square, no? So we need to multiply with the area. So plus or minus 1.48 divided by 19.38 into 19 centimeter square. Okay, but unit we need not to mention, let it be, it vanishes. Okay, then the final value, so this 19, before that we have calculated 19.38 only, no, so both get vanishes. Finally it is plus or minus 1.48. So this error can be round off to the second decimal, then it becomes 1. This is 8 is more than 5, so the 4 become 5, so 1.5 plus or minus 1.5. Okay, so we have calculated the delta A. Now what we should find finally? We need to find the area of the rectangle with the error limit. So area with the error. Therefore the area of rectangle with the error is, the area of the rectangle with the error is mentioned. What is the area? Delta A plus A, no? Yes, it is it is A plus or minus delta A centimeter square. What is the area? The area of the rectangle is 19, no? After round off it. So 19.0 plus or minus 1.5 centimeter square. This is area, this is error. It may be added, maximum possibility is plus, but generally it is a plus or minus. I repeat the question once again. Listen. There is a rectangle is given for you. The length of the rectangle is given. It is 5.7 is the length. Okay, 5.7 is the length, plus or minus 0.1 centimeter. This is the length, and the breadth is 3.4 centimeter plus or minus 0.2 centimeter. We need to calculate the area of the rectangle with the error limit. So first we calculate the rectangle area of the rectangle. Area of the rectangle is length into breadth of. So length into breadth will get 19.38 centimeter square. To round up to the second decimal, it becomes 19 centimeter square. So this is the area. Next error we need to calculate. So for multiplication concept, we know combination of errors we have seen. For addition, subtraction, multiplication, division. Here length and breadth only, no. So the formula is, it is a ratio to the error to the measurement. So ratio to the area error to the area measurement. So plus or minus delta L by L plus delta B by B. Okay. So length into breadth, no. So substituting the value and after simplifications, here we use the cross multiplications. After doing cross multiplication, finally we have the error. That is delta A is equal to plus or minus 1.48 by 19.38. This denominator area we need to multiply with the right hand side. What is the area we calculated? Is 19.38. So both get vanishes. Finally we have the error. This error we need to round up to the second decimal. Okay, then finally we obtain the error. What is the area error? It is 1.5. So the final solution, that is area of the rectangle with the error. Area of rectangle with the error. Area of rectangle with the error is 19 plus or minus 1.5 centimeter square. This is mention common. Okay. Then next we are moving to third question. Okay, now we are going to the third question. Look at the question. The distance covered by the body in a time. Okay, certain distance covered by the body in this certain time. So this is the time t, but this is the error time delta t, and this is the distance covered by the body. So this is s, this is delta s. Okay, calculate the speed of the body and also find the percentage error in the speed. Okay, first we'll write the given. What are all given? The given thing is distance. What is the distance? The distance covered by the body is 40 plus or minus 0.4 meter. Okay, and time taken to cover this time. How much time the body took? The body took 5 seconds plus or minus 0.6 seconds. So this much distance covered by this much time. This is the maximum distance. This is the error, distance error. This is the time taken. This is time error. So as we know, we need to calculate the speed. What is the speed? So speed is, what is the speed? Speed is rate of change of distance. That is, distance by time is called speed. Distance by time is called speed. But they given distance as well as the time. Okay, so easily we can calculate the speed. So how to calculate the speed? Speed is the rate of change of distance. So directly we can calculate the speed value. What is the distance? 40 meter covers the body in 5 seconds. So 40 by 5, which is equal to 8. 8 5s are 40. So 8 meter per second. This is the speed. But coming to the error, what is the error? Percentage error only we need to calculate, no? So distance is equal to speed in time, or speed is equal to distance by time. Next, we are moving to error. Yes, error. What is the error? So the error is delta V by V. Why you use? Because V is used for speed, no? Delta V by V, which is equal to, what is the formula? Distance by time, no? Yes. The distance is, what is the distance? Delta S by S plus or minus delta T by T. Okay. So here it is plus, but plus or minus commonly we'll take it here. So plus or minus delta S. What is the delta S? Distance. Yes. So delta S is 0.4. 0.4 divided by 40 plus 0.6 divided by 5. Okay. So plus or minus using cross multiplications. 0.4 into 5 plus 0.6 into 40 divided by 40 into 5. After simplification, finally we will get the value is plus or minus 0.13. So delta V by V is this value. Okay. So delta V by V is this value. So this is the error. Therefore, the relative error is this much. In the error percentage la solnom. So saying this error in percentage, what is the value? Or delta V only we want, no? So delta V is equal to plus or minus 0.13 into V. V is the speed. What is the speed? Speed is 8 meter per second. So 8 then, which is equal to 1.04. 1.04. Yes, this is the speed. 1.04 is the error speed. We have calculated the error, and this error you should say in a percentage, that is equal to percentage error. So what is the percentage error? Look at that. So percentage error is it is delta V by V into 100. What is delta V by V? It is plus or minus 0.13 into 100, which is equal to, so what is the error value is 13%. So maximum possible value, no? So 13%. We have calculated the error. I repeat the question once again. In there is a certain measurement, some distance is covered by the body in some time taken. Okay. So this is the maximum possible distance. This is the error distance. This is the time taken, maximum time taken. This is the error. So only these alone measurements. This is the error in the measurement. This is distance measurement. This is error distance. This is the time measurement. This is the time error. So calculate the speed of the body. First we need to calculate the speed of the body, and then we need to find the percentage error. So how to calculate the speed? We know rate of change of distance. So distance covered by body in a time. So distance by time is the speed. We leave the error. This much distance covered by body in this much time. That is 40 meter covers by body in 5 seconds. 40 meter covers the body in 5 seconds. That is equal to 8 meter per second. But it is not accuracy. It has some error. We need to calculate the error. So the relative error is the ratio to the error in the speed to the speed. Then plus or minus, what is the formula? We know it's a division only. No, division also we use additions only. because error only could be added, never be subtracted, even though the process may be addition, subtraction, multiplication, division and exponent, but the errors always add, it's never subtract. So delta S, it is a speed, velocity is equal to S, velocity added by velocity is equal to delta S by S, that is C, delta S by S plus delta T by T. So after simplification, we have delta V by V is plus or minus 0.13. Okay, in the error the percentage is percentage error. Okay, relative error percentage is 100 multiply பண்ணனும். So relative error 100 multiply பண்ணா நமக்கு percentage error. அப்ப அதுல எவ்வளவு error percentage இருக்குன்னா 13% is the error. But we need to find the actual error, no. So delta V by V is 0.013 na delta V oda value என்னவா இருக்கும்? The denominator velocity is multiplied with velocity is nothing but speed. The denominator term multiplied to the right hand side. It is multiplied, no. So already we calculated the speed. It is 8 meter per second. So with the error, the 8 meter per second is multiplied. So 1.04. Thank you.